All right, audio and video is up. We are live. Welcome to Senior Seminar. Before we begin the announcements, you got a question about the homework?
Yes, as mentioned in the homework, we have to use scorecards to make our assessments about how projects may do, how the projects will proceed. Well, and when I started, I thought I was looking at operations and maintenance initially on the first problem, but then when I reread it, it said project development. So,
Okay, yes.
what is the difference in some regards? Because that might be.
I mean, the short answer is just, different criteria. I mean, I don't think that you're going to have a loss in comprehension, but you might not have the right answers. Does that make sense?
Yeah, I get it.
But I don't know that I have another answer than that. Like, I mean, I think the ideas will be the same. It's just different responses. Are there any other questions about the homework? So here's what I'm going to do about the homework, because I figure that I should be fair across the board. So let's talk about the status of where we're at in things. So let's talk about the assignments. Homework number 9 was the quiz on math. That's done. That's graded. So what about homework number 10? There wasn't a quiz on homework number 10, and there wasn't an assignment during week 10, and there really was never going to be, because Geotech took 2 weeks. So if you look on Blackboard, it says on homework number 10, or assignment 10, it says skipped for that week, and that's on purpose because of Geotech taking 2 weeks. But then the honest truth is, between advising and having to deal with that, all of that, I did not get a chance to upload the Geotech quiz in time for you all to be able to take it with a reasonable heads up. And so I said, I'll just put it off for later, and we'll figure out a time to do it. I do want to do a Geotech quiz, but in terms of due dates and whatnot, I'm willing to work with you on that. The sustainability assignment's due today. I don't think I'm going to grade it today, but I'll grade it between now and when we come back. I have a test in another class and assignments in other classes, so I mean, I'll be just doing a bunch of grading over break. As for our topic today, I was thinking about doing the software stuff today, but I got to thinking, and the vast majority of you are, I guess I should basically say all of you, are probably going to be in capstone next year or next semester. And while this course isn't it isn't tethered to capstone like it was in the past, what I want to do is I want to talk about the technology tools that you all are probably going to have to become apprised with as you become practicing engineers. But I'm going to tether that to maybe how we'll operate in capstone, because I think I've said this to you all before, but part of capstone, beyond just exposing you to a quote unquote real life design project, as real as we can do it, in an academic setting, I'm going to try and make it as real as possible. But that includes operating in the real world and operating in the days of COVID, where we're using Teams a lot, and we're using stuff like Zoom and a lot of these file sharing processes, and I want to show you a lot of the tips and tricks with Teams and Outlook and all this stuff that y'all kind of need to know when you get out of here, because it's not just solving differential equations. So that's what we're going to be doing when we come back from break. But today, I decided let's do one more FE review, and I decided to do econ because I looked at the flow chart, or the polling that we did, and econ, while it doesn't have as many questions, it seemed like a lot of people wanted to look at it. So we'll do econ as our last topic. The structural engineering stuff, I don't know if y'all knew this or not, but I got a lot of videos about that. So if there's we've got a lot of that stuff recorded, and I mean, I'm teaching steel design next semester, so I'm not really concerned about that. And like I decided not to do materials, because a lot of those materials related topics kind of get talked about in soils when you do sieve analyses and things like that. And then we're starting to get outside my area of expertise. Like I'm not a water or environmental guy, so I decided let's do econ. That'll be a nice close to things. Are there any questions before we jump right into economics land? We do have one other point to discuss. Sorry, but we need to talk about the Geotech quiz. I need to pick a due date for the Geotech quiz, and here's my thoughts. We either make it due the 2nd or we make it due the 9th. And I'm actually kind of thinking of making it due the 9th. I know that's putting it off for a while, but that ensures that you don't have a bunch of assignments due on the same day. And, you know, I'm not saying it's not really a final exam per se, because if you're getting credit for doing it, not how well you do on it. But I don't want to load a bunch of stuff on your plate all at once. So I'd entertain some discussion on that. What are your thoughts? Like, that's not set in stone. Does the 9th, I got one person said the 9th is good. Does the 9th work for others? Oh, I didn't even put my sign on my door. Tell people to let me alone.
What was the question again? I was upstairs for a moment there.
When the Geotech quiz is due, and I'm thinking the 9th.
Of December, correct?
Yeah, that would be finals week, but that way you're not having too quick, because like I said, I was delayed in uploading it, so I don't want to penalize you all. I want to give you time, but I do want to do it because everybody was very interested in doing a Geotech quiz. Does the 9th work?
Yeah, it sounds like it works for me as well.
Well, you're doing one, and that's how it's going to be. I'm trying to think of a pun, and I don't have enough coffee. It's not working. All right. But I did make a Skyrim reference in structural analysis today, so there's that. Okay. Let's get into econ land. So the way I do the econ review is the first thing that we kind of need to just make sure that we're all comfortable with is the time value of money. Now, I'm hoping that everybody has their FE reference manual downloaded. You should. I will add that to the files here. It might take a while for it to upload and to process. It's converting right now. But what we're doing here is, I'd say arguably the most fundamental of engineering economics, problems. That if you can't do this, and I'm not trying to, I promise this isn't like a scary statement, but if you can't do this, then the econ section is going to be hard. So let's take the very first question. If a one-time amount of $500 is invested at an interest rate of 8% per year, what's the future worth at the end of 30 years? Okay, so I'll do this one with you, and let's see if you all can help me out. So we know that the present value is 500. The interest rate is 8%. The number of periods of compounded interest is 30 years, and we're trying to find a future worth. Okay, so what this means is that we have to determine the future worth by taking the present worth and multiplying it by the appropriate discount factor. That's supposed to be a P. Looks like a D. Okay, so what I'm interested in right now is to see if everybody is comfortable, and this FE handbook is still converting, so it might take a while. I might have to just share the whole screen. But if everybody's comfortable with finding that that discount factor, so today might be the day that I sort of force you to, open your reference handbook during class. So I want somebody to tell me, what is that factor? Your future to present, 8%, 30 years. And is everybody able to find that in the reference manual? I'll give everybody a sec on that because this is kind of important.
Are we asking what the value we're multiplying by, or the answer?
Well, really either, but I just want to make sure that we can. What's the value?
If I looked at it right, then it should be 10.1. But that's rounded.
Well, give me the whole value, because it's not just 10.1. It's larger than that.
Well,
or more decimal places than that.
One moment here. 10 point.
There we go.
Yeah, that's basically it.
Yeah, 10.0627. So just to make sure everybody's on the same page with that, let me pull up the handbook. Oh, it's right here. It finally processed. Okay, so here's the reference handbook, and let me see if the as we go from slide to slide, I'm probably going to have to just scan. I think it's like 230. Oh my. Yeah, I'm not going to do that this way because that's going to take forever. Let me.
The page is 240. That's where the 8% charge.
Well, the interface for that through Blackboard is a little weird, so I'm gonna just do it this way. Okay, so here's your handbook. Going to the bookmarks. We're going down to engineering economics. And so if you wanted, you could just compute it, right? You could just compute it by taking 1 plus I raised to the n, right? So it'd be 1.08 raised to the 30 power. And so if you do 1.08 raised to the 30, you get the same factor, But we just keep on trucking through the manual. Here's our MACRS cost recovery, our depreciation. And here we go. So here's our interest rate tables. Keep on trucking. Let's see. Here's the interest rate at 8%. And then we're talking about a number of periods of 30. We're talking about 30 periods. So there's 30. Here's the F over P, and F over P is 10.0627. And so 10.0627 times our factor ended up being, I think it was, what was it, $5,031.35, right? So there you go. That's the answer. So let me stop this share and let me get back to, here it is. Okay, so this one, so we're taking F equals P times our interest rate factor for, which is 500 times F over P for 8% for 30 years. So 500. I can do better on that. And then, as we said, 10.0627. And so that ends up being 5,031.35. Okay. And so I can tell you that being able to do this is kind of critical that you just kind of need to do this on, be able to do this on the econ section. So with that, somebody see if you can just do this one. I want to give you all a second, see if you can just do it. I want to, yeah, so somebody tells me or tell me what that answer is. We'll say to the nearest penny whenever you have time, or whenever, I mean, whenever you get to it. Anybody got an answer? Well, let's write down a few seed values, okay? So we know that, okay, we need to have 500, or sorry, we need to have $800 at in savings at the end of 4 years. There we go. Yeah, exactly right. Okay, so let's walk through that real quick. Perfect. Yes. So just to make sure everybody's on the same page, so we're trying to determine our present value, and we know that we have, we want to have $800. So that's our future value. So it's basically kind of an inverse. We're trying to find a present value based on a desired future value. So this is F P to F I N 2P given F. And so this is $800, $800, and then P over F for 5% for 4 years. And so that is, what's that factor? Let's see. I don't have that written down for some reason. Oh, that's interesting. I don't have that written down. You want to know why I don't have that written down? Because there's not a value on the table. I remember this now. So because this is not listed, and the reason it's not listed is because it's 5%, we have to compute that. And how do you compute P over F? It's 1 plus I to the negative n. So this is 1.05 to the negative 4. So this one you have to compute. And so this is, as you said, 658.16. I know I had a reason for doing that one. Okay, one more, and then we'll get into some like real problems. Now this one, I believe you don't have to. Yeah, this one you don't have to compute any factors. But this one requires you to think a little bit. It's a tad more challenging. Make this big. There. I'll give you a sec on this. The kicker is to think about what it says here with this 12% nominal annual interest, but where it says compounded monthly. So let's walk through a couple of things. So we know that the present value is 100,000 because the company borrows that money today on a 5-year loan. Now here's the thing, 5 years at 12% nominal annual interest compounded monthly. So, all right, hold on that, Mr. Atkins. So first off, if it's 12% nominal annual interest compounded monthly, how many compounding periods is it? It's 5 times 12
60
or
periods.
60. Yes. All right, I'm gonna have to turn my volume down because that scared me. All right, so 60 periods. So the interest rate then is not 12%, it's 12% divided by 12 or 1%. So it's a 1% interest period. And what we're after is the annual worth. We need to know what that annual amount's going to be. So A is going to be P multiplied by A given P. So then it's A given P for 1% for 60 periods. And so what is that factor then, and what's the answer? Because I'm getting a different answer than you, Mr. Atkins.
Yeah, I went with the 12% table, not the 1% table.
Yeah, that's probably why. Yeah. So this one, I'm getting a factor of 0.0. There you go. 0.222.
That checks out within the 0.0222 checks out in the table as well.
Yep. And so the one thing to keep in mind whenever you're doing these problems is, does the answer kind of pass the gut check? If I'm borrowing $100,000 on a loan, and I'm going to be making 60 payments, if you've got a $12,000 payment, that's man. I'd give that loan, because I'd be making some bank at the end. So just make sure that you've got that gut check done on your calculations. All right, let's do some real problems. Okay, so let's start off with example 1. The Powerball was won by a single individual. Okay, so first off, I'll walk you through sort of the rest of these, because the first one was really, these first set of practice problems were trying to shake off the rust. Now that we've kind of shaken off the rust a little bit, we can kind of knock out some of these econ problems a bit faster, because it's like now I can run through it and we don't have to go, okay, where'd you get that factor? Like we kind of know where that stuff's coming from. Okay, so the Powerball was won by a single individual, and the individual was given 2 choices: receive 26 payments of $7 million each year, with the first payment to be made now, or receive a single equivalent lump sum payment. Now, if the state uses an interest rate of 4% per year, what should the amount of the lump sum payment be? So here's what we're going to do. First thing we need to do is we need to look at a cash flow diagram. Okay, but before I do that, I want to point something out. So let's see if you all remember this from econ, right? So, this is year 0, this is year 1, this is year 2, this is year 3, this is year 4, etc., right? And whatnot. So, whatnot. Okay. So remember, when we define the variable P, right? P begins in year 0 or in period 0, but your annual worth begins in year 1, right? Year 0. Begins in year 1. So what I want to focus on is some of the wording on the problem. The problem states receive 26 payments of $7 million each year, the first payment to be made now. Okay, so if I look at a cash flow diagram for this problem, here, let me write it like this. All right, so what do we have? We have 0, 1, 2, 3, and then that's going to go on and on and on and on. So, and then, you know, maybe this is like 23, 24, so on and so forth. Okay, so we're going to make one payment of 7 million now, and I'm just going to write 7. I'm not going to write 7 and 6 zeros. So 7 million now, and then another $7 million payment in year 1, another $7 million payment in year 2, another $7 million payment in year 3. And I'm going to keep doing that until I hit what year, right? I'm going to have one in year 23, one in 24. When am I going to stop? I want to make sure people are reading the problem. When am I going to stop? Now think about that answer, Mr. Schwartz. There you go, 25. It's going to be year 25. Because there's 26 payments, but the first payment's now. So think like in year 0, we have a payment. Year 1, we have a payment. Year 2, year 3. So like take at year 3, we've had 4 payments. So on year 25, we'll have 26 payments, right? So it's kind of a trick wording, I know, but so I guess my point I'm making is my number of periods is going to be 25, not 26. My interest rate 4%. Here's what I proposed. Okay, what I'm ultimately trying to determine is a present worth, right? And so my present worth, I'm going to have obviously an annual value that I need to convert. And so maybe I'll just shortcut that, right? But remember, annual worths begin in year 1, right? So this is my A. Keep in mind, I also, let's not forget, that's $7 million I received today. So I'm going to take, so there's 26 payments, right? 25 of them are made in the future. So I'm going to take those 25 and convert them to a present value. But that first one is made now. So I've got to add that to what's going on right now. So this is $7 million times this factor plus $7 million. What is that factor? Well, to a present worth given an annual value, 4%, 25 years is 15.6221. So I don't need to look that, or I don't need to rush that. By now, you all can look these up. So $7 million times that plus that $7 million in year 0 gives you 116.35. Does it make sense? Like the kicker is I want to make sure you understand that part, that I added that $7 million at the end, because there's the 25 payments in the future, but there's that one payment that we're making right now that we can't forget. I want to give everybody a sec on this. Any questions? Do I need to give you a sec to copy this down? Oh, what happened? It scrolled away. There we go. Are you all good, or can I move on? I'm not hearing anything from the class. So I want to make sure. I don't want to skip ahead. Okay. All right. All right. Let me. What happened? I had an audio setting mess up on me. Okay. Let me drag this down. Give me a sec. I want to make sure I got room. I sort of screen clipped all my examples, and so I don't want them to like bunch up. Okay. One problem that is very possible on the exam is a salvage value problem or a present value problem. I'm hoping that like you all have seen these before. So I've only got one component of the problem. I'm going to just determine the present value of machine X. But what you could do, like the sort of follow through to this problem is determine the present value of machine X, determine the present value of machine Y, and then you can do a cost comparison to see whether or not you should go with one machine or the other. So it's an analysis tool to determine which machine is the better deal, if you will. And so in order to determine the present worth of a machine, we have to incorporate not only its initial cost, but its annual maintenance cost and the salvage value at the end of the year. And so I threw some sign conventions on here, and the sign convention that I use is basically the idea is how this is going to hit my wallet. So let's take machine X. On day one, I'm gonna have to spend about $66,000 out of my wallet on machine X. Okay, so machine X is gonna have a present value initial cost of negative 66,000. And then the annual cost is going to cost $10,000 a year. That's negative. That's out of my wallet, right? But the salvage value is positive 10,000 because at the end of the day, I'm going to sell that machine to somebody. And I'm going to get the money back. So that's going to go into my wallet. So that's why that's positive. And then the life of machine X is 6 years. So what's its present worth? So all the present worths, according to my sign convention, are negative because there's still a cost. Like I still have to buy the machine. The idea is, which machine do I buy? Do I buy machine X or do I buy machine Y? And fortunately, these are kind of straightforward because if I want to determine the present worth, all I'm doing is the following. I'm taking negative 66,000. So we're doing machine X, right? This is the present worth, the worth at year zero. And then I'm adding to that, I got to account for the maintenance cost. So this is the annual worth, right? So that's A. And then times its, appropriate discount factor, plus the salvage value. And that's money I'm getting at the end of the life. So that is definitely a future value. And so I'm assuming you've done stuff like this before in econ, and this is admittedly probably pretty basic compared to the stuff that you've done in econ before. But again, it's the FE exam. It's supposed to be fundamentals. So does anybody have a present worth of this? I'll give you a sec on this because I know you got to look up some quantities. Yeah, today's the day I definitely want you using the manual. And I'm making you sort of look up a lot of values in the manual today because, I mean, this is kind of what the FE is like. You've got to do the problem and then go to the manual, look up the value. And so I want you to kind of get used to that. So this one, I'm putting you to work a little bit. Excuse me. All right, that's I got an answer here, negative 103,908. Do I have a second on that? That's a negative, by the way. Let me. Yeah, there you go. So, boom, that one's easy. So yeah, I mean, what you could then do again is you could take this and do the same thing for machine Y, and then determine, okay, I've got machine X, machine Y. Which one's gonna hit my wallet the less or the least, and that's the one I'll purchase. Okay. All right. This one, I don't want. These are the types of problems that you could get in engineering economics land that I find that they're like, sometimes students think that they're so easy that they're hard, and then they don't do them. But this is really a plug and chug problem. So an interest rate of 12% per year compounded monthly is closest to an effective rate per year of what? So the idea is I have an interest rate. Let me use another color. My interest rate is 12% or 0.12. And then the number of periods, or the compounding periods, is 12. So do you all remember this formula? Hold on. Y'all remember? So the idea is that I have an interest rate of 12% per year, but it's compounded monthly. So because I'm compounding it monthly, I'm actually accruing more interest within that year than just 12%. So I'm trying to figure what that is. So this comes out to, it's like, hold on, 0.126825, something like that. Or let me see. Oh, what happened there? Oh, what happened? I'm sorry. Hold on. Hold on. I closed it. I didn't mean to close it. I was trying to pull up the manual. My apologies. Hold on. Sorry. I was trying to pull up the manual to show you where that formula is. So sorry. So here's the section of the manual. So I'm just going to you know, the table of contents and going to engineering econ, the first thing that you see are your discount factors all named out, and all the formulas, the nomenclature. And it literally, if you go to the next page, non-annual compounding's right here. So it's not as if that formula is that hard to find, just right in the manual. So effective interest rate based on an interest that's not compounding. Does anybody remember the formula for continuous compounding, if it's compounded continuously? I'm just seeing if anybody remembers that. I'll bring the notebook back up. Does anybody remember compounded or continuous compounding? Does anybody remember that? You take the principal times E raised to the R times T. Sorry, I couldn't help it. It's truth, though. That's the formula. Get it? Pert. Sorry. Okay, I'm done. All right. Last problem I want to. Sorry. Last problem I want to do with you is the is one on depreciation. So modified accelerated cost recovery system depreciation. I have a machine with a 5-year life. It has a first cost of $50,000 and a $20,000 salvage value. So using MACRS depreciation, book value at the end of year 2 will be. So we have, oh, not ready. Year, I know we're probably running out of time, so I'll do this one kind of quickly. So year 1 and year 2, we need our MACRS factor, which again, you can get that from the manual. So that's 2032. Yeah, we're running out of time, so I'm going to go through this one kind of quickly. So your depreciation in any one year is just, 20% or 32% of your first cost. And so 10,000, 16,000, right? So your total depreciation is 26,000. So the book value is going to be 50,000 minus that. So 50,000 minus that is 24. I guess that one was a little faster than I thought it would be. I thought it would be faster. Well, what happened? I had my letters A, B, C, and D. I guess, yeah, that's supposed to be A, B, C, D. I don't know what happened there. My Surface is getting warm. I've been using it a lot today. I'll give you all a sec to catch up, and let's see if anybody has any questions. Hopefully I didn't go through that one too fast, but I think that one's pretty simple. I mean, the one thing I think about the econ section on the FE exam that I've always found is that it's not terribly difficult. It's just you have to know, you know, the factors, and you have to know where they are and be able to locate those and navigate the tables. But I've never really found it's a terribly difficult section. Any questions? Is everybody good, or do you need me to scroll up, scroll down? You let me know. So let's see, check. All right, everybody good? Okay. All right, so here's what we're going to do. I'm going to post the econ quiz fairly soon. That one's usually not too bad. It'll either be posted today or tomorrow. I will start grading the sustainability homework probably sometime later this week, maybe a little bit into next. But by the time you all come back, the sustainability homework assignment will definitely be graded. And with that, that is pretty much all I have. I'll post the econ quiz quick. It'll be due the 2nd, which is the Wednesday we get back. And then we'll have our last lecture in senior seminar. So you guys are done with me until we get back from break. I wish you all a very relaxing break. Try and take it easy. Try and reset, recalibrate. You know, eat a bunch of turkey, or if you're a vegetarian, eat a bunch of mashed potatoes. That's all I have, everybody. I will see you all when you get back. You all have a wonderful break. I'm going to stop the share, and I'm going to go ahead and log off. I will see you all on December 2nd. All right. Stop.